Hello class, in this video you will learn how to write a recursive function by calculating the factorial of a number. So let's start by looking at the code, and I want to do a little bit review of math, probably algebra 2. So this is the definition of a factorial of a number in algebra 2. I hope you still remember. So factorial of 1 is 1. Factorial of 2 is 2 multiplied by factorial of 1, or 2 multiplied by 1. Or we can rewrite as 2 multiplied by factorial of 1. Factorial of 3 is 3 multiplied by 2 multiplied by 1. Or you can rewrite it as 3 multiplied by factorial of 3 minus 1. Or you can write a general formula by saying factorial of n is n multiplied by factorial of n minus 1. So that's how you calculate factorial in math. So let's see how you do that in programming. In this example, you're going to learn how to write a recursive function. Then you may ask, what is a recursive function? Well, it's very straightforward. Recursive function is a function that calls itself until it reach a base case argument, and then it doesn't call itself. So this is an example of recursive function, a function that calls itself. So let's take a look at the code and see where we call ourselves. So this is a factorial function, right? There is one line of code on line 21. It calls itself. Factorial is itself, but it passes in a different argument, that is n minus 1. So that is an overall, the overview of a factorial function. The factorial function is a function that calls itself. So what's the principle or what the rule of writing a factorial function? First of all, you need to figure out the base case. The base case means you have to get the result or you calculate the result without calling yourself. So in this case, factorial of 1 is 1 and factorial of 0 is also 1. So we say the base case here is factorial of 1 or factorial of 0. So my base case is n. If n is 1 or n is 0, my val, which is the factorial value, is 1. So that's my base case. If n is not 1 or 0, then we follow this math formula, right? So we say val, or the value of factorial, is n multiplied by factorial of n minus 1. So we are calling ourselves. This is a recursive call. We are calling ourselves, or we say this is a recursion step, right? The difference is on the current call, we type the input parameter n, but when we call ourselves again, we pass in the value of n minus 1. That's what the math formula tell us, right? There are a few things in terms of data definition, data type that I want to point out in case you haven't learned it before. So if I say int factorial, the type an integer, return integer, that is straightforward, simple, right? How big is an int? That's a 4-byte quantity. What about long? How big is a long? Long is also a 4-byte quantity. So long is the same as an int. Now, my data type or return data type is long. So double the type, double long. So what is long? You know, if long is 4 bytes, then long means this is an 8-byte quantity. So we take an integer, but the result could be a lot bigger than integers, right? So integer is 4 byte, but we say when we calculate factorial, the result could be humongous. So we're going to use the data type long instead of integers. However, you can do int too, but you may run into overflow. So that's the data type. So val is the value of factorial. So that's what my data type for the local variable that I will return is on so long. So I initialize the return value to be 0, and then I do cout because we're gonna trace the execution of this function later. So I want to see how we enter the function with what value of n and how we exit, or when we exit, what the value of n is. And we go through this if, which I just briefly talk about. The base case is if n is 1 or 0, I don't have to call myself. I just say the factorial value is 1. If n is not 1 or 0, then I'm using this formula. The factorial is n multiplied by factorial of n minus 1. And then the recursive call will figure out the result for me. I don't have to worry about it. So it's easy to write code. And after I get back the result, then I print or I do cout exit factorial. I want to see cout of n and also the factorial value, val, and then just return to the caller. So what is my main program? What does it do? My main program declare an input value, long num, or I can just say int. You can do either, doesn't matter. And then I ask my user, please enter a number to calculate the factorial. Then I read in that num, and then I do cout of num factorial, which is the exclamation mark, and then I call factorial and I give it num. And then the factorial functions will figure out what the factorial value is, and it will return to my main program. So let's run this code and start with small input number, and then we increase it to a bigger number, and then we trace the execution. So let me move this output window over here so that it is out of the way, so I can show the code and the output at the same time. Okay, let me move this window over here. All right. Okay, so I'm gonna try with very easy base case. That's 1. Let's see how that works. So right here, I ask my user enter the number to calculate the factorial. Then I call factorial and I enter 1. So I'm calling factorial of 1, right? Factorial 1, I come in here and I hit the base case. Because n is 1, then val is 1. I don't need to call myself. I just say exit, right? So you see over here, enter factorial n equals to 1, and then exit. Factorial n equal to 1, val is also 1. I hope you still remember what \t stand for. It is the tab key. So I'm gonna use the tab key so that it give me some spaces or blank between n and val. And then I just return 1, return back to here, and the program, the main program, print factorial 1 is 1. So let's run it again with 2. See how it calculates factorial of 2. Calculate number, enter number, right? 2. Now let's see how that works. So from here, I'm calling my factorial function. By the first instance here on line 16, that I'm taking n equal 2. That's what you see right here, n equal 2. And then I check the if statement, say if it is 1 in this case, n is 2, so it's not the base case. So I need to go on, to execute the else clause, right? So the else clause said val, which is the value factorial, is n multiplied by factorial of n minus 1. So n is 2, then I'm calling myself, the factorial calling itself. But this time it say, please calculate the factorial of n minus 1, which is 1. So I have not completed this execution yet for n equal to 2 yet, but I need to call myself, right? So I'm calling myself with n, with the value of n is 1. Then I go here, okay, initialize to 0, and then n is 1, so val is 1. That's what you see over here. Enter factorial of n is 1. If n is 1, val is 1, done. I don't want to call myself. So I said, okay, done for n is 1, then exit. And the exit say n exit factorial n equals 1, and val also equals 1. Now, we have not finished the previous function call of n equal to 2 yet because we call ourselves. So we need to get the result of n of factorial of 1. So we got the result of factorial of 1. Good. So we just take 2 multiplied by 1. We say, oh, okay, we got the result. We got n is 2, then multiply by factorial of 1, which is 1. So now we exit. And that's what you see right here. After we exit the base case, now we said we got the result back, so I can calculate the factorial of n equal to 2, val is 2. So we print val equal to 2, right? Then return val. And that finished the recursion. We don't need to do any more recursion when we call ourselves. So we return back to the main program, and it's a 2 factorial 2, right? So let's trace the case where 3, see what happened. So you see 1, 2, now let's try 3 and see how many recursion we need to do. 3, same thing, similar to 2, right? So we said, okay, I'm calling factorial, and that's in num is 3. And that's what you do. Then we come here and we say enter factorial n equal 3. That's what you see right here. Oops, sorry. N equal to 3, right? And so n equal to 3, so we're not going to do line 19 because n equal to 3, we said, okay, that's not the base case, so let's go on. Go to the else clause. And the else clause said val, which is the factorial value, is n multiplied by factorial of n minus 1. So currently n is 3, so we're going to call factorial again. We call ourselves with n with the argument of 2, or when we call ourselves, now n is 2. Now n is 2, we come here, then you see it's a enter factorial of n equal 2. Now we do execute the same code. N is not 1 or not 0, so it's not the base case. So we're going to go over here and we say, n is 2, so my factorial is 2 multiplied by factorial of n minus 1, which is 1. So we're calling ourselves again. We have not finished n equal to 2 yet because we just keep calling ourselves, right? So now we're calling ourselves n equal to 1. Then we go back here, and then that's what you see right here. It's a enter factorial, n equals 1. So when n is 1, that's the base case. So val is 1, we're not going to call ourselves. We're not going to call ourselves, we just assign value of 1. Then we go down here, we say exit that factorial n equal to 1, and then val, print val. And that's what you see right here. N equal to 1 and val is 1. So we keep calling ourselves, but we have to terminate the recursion when we hit the base case. So that's the base case. So once we already figure out factorial of 1, the val is 1, the value of factorial is 1, then we said, all right, so we got that value. That means we can complete this calculation for n factorial of 2. And that's what you see right here. N factorial of 2, val is 2. N factorial 2, val is 2. So we just finished the recursion call for n equal to 2. That's done. But then we look at it and we say, what about n factorial n equal to 3? We haven't exited that n value yet. That is correct. We have not, because we need to figure out the other case, n1 and 2, excuse me. So now we said, okay, we got val, exit factorial n equal to 2, val is 2. Got it. Now we replace that value of 2, go back and calculate the factorial of 3, which is what we're looking for, right? So we got 2 multiplied by 3, and we print, so that the result is 6. Val is 6. After we do that, when val is 6, we return val to the main program. We finish the recursion. So the main program said, all right, we got the result. Factorial of 3 is 6. So that's an example of factorial of 3. So you can run this code, trace the code, and use bigger number to see how that works. And if you want, you can just write more cout statement in here and then see how that works. So the next question is, can I write functions, or can I write code or function that calculate factorial without recursion or without calling myself? The answer is yes, you can use a for loop. It should be straightforward. You can use a for loop. However, when you write a for loop, the for loop code is a little bit more complicated than just doing this. So if you just say, I want to write easy code, then recursion makes a lot of sense, because it just uh, translate the math formula into programming and using the exact formula. So it's easy to write code, but what's the problem with recursion? Well, the problem is every time you make a function call, you are consuming a piece of memory on somewhere in the memory. In the program memory, it's called the stack. So every time you make the recursive function call, you will consume a block of memory, because the system needs to keep track of the local variable val. Because every time you call with different value of n, val is different. It's not the same local variable val every time. It's the different variable val each time. So if you calculate factorial of 1 million, for example, you're going to consume significant amount of memory, because each recursion call is not free. It's going to consume a block of memory on the stack. So number one, memory consumption is big when you have a big factorial number to calculate. Number two, debugging recursive function call is not easy. It's real hard. It's really hard to debug, because you have to figure out what iteration are you on. and it's very hard to figure that out. So in real life, we try to avoid recursive function. However, we just want to learn how to write it. But in real life application, if you can avoid it, it's better to avoid it without using recursive because memory consumption is not great for humongous number of recursive. Also, debugging is a nightmare. So that's the problem with recursive. And the benefit is very easy to write code. You see, that's a formula. Then you just translate in the code, and the recursive will take care of itself. So you don't have to worry about, oh, how do I figure out to calculate the factorial? Just use the math formula, and that's it. It'll work fine. Okay, so that's the end of this video. See you in the next video.